Today on the Messy Workbench we have this. This is a Kriesler 11-99. I bought this on Tuesday and it arrived yesterday, which yesterday was Friday, so that was really quick. I got this for pretty cheap actually. It was, I found the exact price, but yeah, it's a nifty little radio. It's a 4-tube, well this one in particular is a 3-tube, and I'll get to that in a minute. From what I can tell, this was built in 1974. It's a nifty little radio. It's runs off the mains, but has got a carry handle on it. So we're going to do a recap of this thing. I've got the schematic on my phone. I've got the replacements for the old wax capacitors. These has old Ducon wax capacitors. So yeah, let's recap this thing. It's a nifty little radio. Oh, smooth volume control, which is surprising. It doesn't feel all gravelly. This does have a new power cord on it though. So this is interesting how you have the antenna and earth connections, which are the two screws that hold the back on, but it does have a ferrite rod in there, so you don't need to hook these up. It's only if you really wanted to get that better reception. So just undo these. Yep. Nifty little radio. It's pretty small too. Pry this off and try not to break it. It is modern plastics, but you know, it is old plastics. Okay, yep, you can see the Ducons in there. I did open this not long before I put it on the bench because I couldn't wait. This hat has its power cord definitely replaced. It's more of a modern power cord with the modern blue, brown and earth. Because real old power cords did just have red and black for positive and negative. So this is our audio output tube. That's a 6GV8. We have a 6N8. It's a IF amplifier, and this is our detector. Like I think it also amplifies as well. It's a 6AN7. That's pretty nice. I get the date code from here, 74. So I mean, like this is dated 73 and this is dated 66. So it's made from parts all over the joint, but you know, it's a pretty nice set. It's got all the original tubes. I reckon this is a pretty low hour set. Really. Kriesler always put in Philips mini watt tubes in their radios of this time period. So I haven't taken this out all the way. It looks like there's some flat screws I have to get out of there. I'll get a close-up shot for you. You can see the specific serial number. This is probably a very late set. It's definitely one of the last vacuum tube radios that would have been made here in Australia. See that? These IF cans, I haven't experienced any IF cans made in these Kriesler radios that have silver mica disease. I haven't actually seen silver mica disease. I know it's a thing that's always seems to happen in all American 5 sets, but I haven't actually witnessed it here in Australia, especially in a Kriesler set. These are pretty good and long lasting, I've noticed. Transformer looks pretty good too. Very little bit of slight rust there, just on the very surface, but that's pretty good. Audio output transformer looks about the same. So I'll just unscrew this thing and get a closer look at it. But there you go, there's your Ducons. Obviously they're all going to need to go. They're all 0.033s at rated for 200 working volts. So I've only got these orange drops, which, you know, are rated for 600 volts, so it's a little overkill, those, but that's what I got. I know there's some 0.022s in there as well, so I got some 0.022s. Unfortunately I don't have some 0.033s, but I do have some 0.047s, which will, you know, they'll work fine. It's alright to go up in capacitance a little bit, it won't affect it too much. I mean, the valve radios are very tolerant to things like that. These definitely aren't. These are just the two things that have been replaced in here other than the power cord. It's, yeah, it's, what is this? It's an old Ducon electrolytic, 100 microfarad at 200 working volts, and this is a 50 volt Elna, and that's only rated for 150 working volts. Well, this thing would get a bit of a shock when you turn this on, because this has a diode in it, which is why it's only a 3 valve, because these later versions omitted the 6v4 and put in a one day solid state diode in there. So I'll get this thing out of the front and I'll be back. It's just taking a look at this, try and get it at an angle that you can see it. This old rubber on the tuning coil, it's still good. It still actually moves around, so that is genuinely surprising. Yeah, it still rocks around, if you can see that. So, nice. So you know it's not that old of a set. So if I take a look at the front here, you can see the original speaker. Solid metal front, which is interesting, and there you go, there's your volume pot, tuning dial. Interesting way of mounting it. Oh, 1-to-1 mechanism there. No tuning dial, which is nice, so I don't have to replace it, but it also means that actually tuning the radio into a frequency can be a little bit of a, can be a bit coarse and sometimes a bit hard if the signal's faint, but that's just nitpicking at this point. This volume control feels very nice. A little bit of corrosion on the old screws, but overall not too bad actually. Just needs a good clean. Have a look in here now. You can see exactly what's going on. There you go. A little bit of a pan in here. See all the older wax capacitors. And there's your rectifier. So it's only halfway, well, half rectification. Doesn't rectify the negative wave, but the original circuit with the 6v4 did the same, because the secondary on this doesn't have a center tap. So you can tell that the old cord has been replaced even if you haven't seen a photo of the radio online, because this is the original cord in here. It was a white cord, and this feeds over to the power switch to complete the circuit on the primary. And then you just get the 6.3 volt and the 115 volt AC, and it's rectified. This Elna is darkened a little bit around here, kind of orange. I don't know what that story's about. Just up here, you can see that. Here's a better look at this Ducon. There you go, Ducon electrolytic. Now, I've noticed on this electrolytic, which is something you should really watch out for. I'll get on. I'll take this on a bit of a better angle so you can see it a bit better. But see this little strip here, this tag that's got nothing attached to it. That is connected straight to ground, and this is the DC, about 120-ish volts, coming straight off the rectifier, going to the electrolytic. This Ducon had too much lead, so they just folded it over, which in this case is a really bad idea, because in case this thing goes a bit too close, see how close that is? That is ridiculously close. If that goes too close, they can actually short that out to ground, and that would put this rectifier diode straight across the transformer, and this thing would either explode instantly or it would get really hot, and it would also burn out the transformer. So we're going to have to rewire this for now. I don't have an electrolytic of this capacitance, a 40 microfarad, but I have ordered one, the Nichicon. You could get 5 for only a few dollars, so they haven't arrived yet, but we'll go through and replace all these wax capacitors and see what we can do with moving this wire out of the way so it can't short out no matter what, because you just have to watch out for stuff like that. Another thing that not a lot of people really think about is insulation between the body of the radio and the wires, because see how hardly any of these wires actually have some sort of insulation between them and other components? Well, that's why I have this. It is a very old roll of clear plasticness that you would find in these radios, and you do actually see it over here. Just here, it's the same sort of stuff. This is a bit of a wider gauge stuff, but you know, it is actually used in this radio in a couple of spots. So when I put in these new wax capacitors, I mean, well, not new wax capacitors, but replacements for the wax capacitors, I am going to use that stuff to insulate the wires. I have looked at the schematic, and even though I'd be putting in a slightly higher capacitors in here for the 0.033s, it won't really matter, because these just go across the plates, across the high voltage to ground. They're just used for, so they're just some basic filtering. They don't really do much there. I have replacements for the 0.0022 up there and stuff like that. They're the ones that actually carry the audio. So this 0.022 here, that carries audio. This one carries audio. This is the audio output tube. This has a triode first amplifier. So this goes to the triode side. This is where it gets the audio in from the IF, and goes through a capacitor and turns it into just normal audio. So goes to the triode amplifier, then it goes through this capacitor to the, I think it's a pentode, and then it just goes to the speaker through the transformer. So it's pretty simple circuitry stuff. It's a pretty simple, straightforward radio. This, if anyone is getting into valve radios for the first time, this is definitely a recommendable radio, just because of how straightforward it is. It really allows you to get a good grasp of how these things work. I mean, you know, you've just got 6 wax capacitors in here, 2 electrolytics, and you know, bingo, bango, bongo, you're pretty much done, unless you got a few resistors that have gone high in resistance, which I did check a couple have. I think one's gone more than double its rated resistance, which is well and truly above its, I think, 10% tolerance. So we'll be replacing that. Most of these are alright, but a couple have just gone out of tolerance, which, you know, you get with age like this. And to assist me with this journey is my cup of hot chocolate, which, you know, lovely cup here from the Titanic art exhibition that happened quite a few years ago now. It's just in Melbourne. So yeah, I will definitely need that during this. So yeah, let's start with the audio ones, I guess. So I'm just going to start with removing this 0.022 right at 400 volts. So a bit of solder and that's it. What is really good for this, I've noticed, is get something like a hook like this that you can just get on the lead and just try and pull it out once the solder liquefies. Sometimes it can work, sometimes it won't. Yeah, sometimes like this they actually wrap the wire around, so you won't be able to just pull it out like that. So all you have to do is just snip it out and then heat it up and pull it out on the other side generally. So it can be a little bit tedious, but in the end it's worthwhile. Oh, yep, there you go, there it is. There's the hook. Oh, I can see it. I don't know if you can. Yeah, it's definitely in there. I might actually solder suck this thing. Might just try and get in there and... Yeah, generally might have to do this a couple of times. So what you do is, if it doesn't get all the solder, you just flow in some fresh stuff. You want to be, you don't want to keep it on here too long, because heat on it too long, because it, you know, shortens the life of the components and everything, stuff like that. Yeah, a bit like that. So you can see it's just this little hook there. So if I don't know, I'll fiddle with it a little bit. There it is. Just try and get it off. It looks like it's wrapped around twice. What I'll do is let it cool down, and then I'll chop it in half. Then I'll flow it again, and that should allow me to pull it out. And just get around it like that. There we go. That pulled that out. Is gone. Finally. So that leads out of there. So, you know, if you're having trouble getting the old wires out, don't just give up on it. Actually, tear into it a little bit. You know, it'll be a lot better worthwhile. You know, it's always better to do a good job of stuff like this. You know, just take it easy, go through it, and in the end you'll get a really nice looking job. So you can see how short of a wire I put in here, how short the leads are on that. So that fits in there correctly, and it's looped around. It's a lot better than having this long lead looping around just to go in. I was able to do this because the capacitor was so much smaller, so I could just go straight across like that, and yeah, it looks pretty decent. Yeah, I didn't need any insulation on the wires because, you know, it's just so short. So I'll just continue doing the rest of these capacitors, and then we'll move on to the resistors. So I'll finish replacing these two capacitors here and here, and this is on the audio output tube, and this is where it is in reference to the manual. So the first 0.002, just this one here that comes off the volume, and this is just a triode, and the next one is a 0.022, which feeds to the grid of the other side of the tube. So pin 1, 2 and 3 are just on this tube of the triode. This is a 6GV8, so it's a pretty interesting little thing. And so yeah, they're the main two capacitors, because they do go to the grids. Because they do go to the grids of the tubes. These other wax capacitors are just filtering, so if they went short they would probably blow apart, but they probably wouldn't damage a tube, but they could blow up the transformer or diode. So that's them, and you can see I put a sheet in there which goes to the potentiometer. So yeah, they're in there. What I've decided to do is plug it in and check some voltages now that I couldn't bias the tube heavily with some bad capacitors, even though the plate of this triode is only 30 volts. 30 volts on the plate, it's really low voltage for a valve radio. But okay, that's on. Instant high voltage. See what we get. This potentiometer is still good, that's amazing. Didn't think it would really pick up anything, but you know, check the plate voltage. 30 volts, look at that. Spot on 30. That is pretty good after all these years. And on the other side of this, -5. I guess that's because, oh yeah, that's connected to the bias on the other side. That goes to the 1 meg ohm through the bias, and then that goes through a 470 ohm to the grid of the next tube, which is that one, which is still -5 volts, and that comes out on the plate, which is so is that pin 9? Yeah, that's pin 9, that's the grid. 9876. So that's this one, is it? Yeah, 120. Oh wow, 126 volts. Damn, that's 20 volts higher than what it should be. According to the schematics, it should only be 105. And it goes through the coil to high voltage, so it's 136 volts straight off the diode. and it's 94.5 off the Elna. Yep. Well, that's all working right on that power tube, so I'll let that power down. Watch the voltage fall. Well, it's dropped pretty fast. It's already at 3 volts. What is on that side? 3 volts, yeah. Drops pretty quick, but there you go. So, you know, nothing wrong with the circuitry in there, obviously, what I've done to it, because it's working fine. Yeah. Okay, so it's been a little while, and I've gone through and recapped it. As you can see, you know, there's only 6, so it doesn't take too long. And I also replaced a couple of these resistors because they were way out of tolerance. The other ones are alright, but you know, there's just a couple that weren't. Last thing I'm going to do is move this positive lead away from the ground tab, you know, just to make sure it doesn't short out. And then we'll do a IF alignment on my recently restored RCA signal generator. It's just sitting there warming up for a little bit before we use it, just to make sure it doesn't fluctuate during the procedure. And yeah, I recapped that a while ago, and now I can finally use it on something, so you know, it's going to be interesting. So I've changed my mind about doing an IF alignment on it. I've been using it for a little while, and I find no need to really do an alignment. And I don't have any plastic flat blades that I can use in this thing anyway. But I have replaced the dial light. Here's the original. Let's see if we can get a close up on that. You can see it says Philips there. It's the original. It's burnt out. So that's the original bulb, and you can see a good indication of how many hours this thing has done by how much it has darkened. So you know, it's a pretty decently low hour set, but by just how much these have darkened, it does make me question a bit how much life is left in these tubes. But unfortunately I don't have a tube tester, so I'm gonna have to make do for now. The radio does work, so can't really complain. But what I have decided on doing is that this power cord up here, it is really thick, so much so that it can't really get through the case. And so I'm going to replace it. There's nothing electrically wrong with this cable, it's perfectly fine. It's just it stresses the case a bit, and I don't want the case breaking and cracking, because you know, that destroys the value of the radio. So I'm going to change it. The original cord didn't have a ground lead. That's basically the main difference. And this has a thicker insulation than most cords, so I'm going to replace it with this lead I have here. Can't remember what I got this off now, but you know, it's still got all 3 wires, and it's a bit thinner, and it won't stress out the case, so I'm going to use that instead. So I'm going to change that over now. I have, as you can see, moved the capacitor lead out the way. You know, safety first. Always a little bit paramount with these radios. So yeah, it's interesting to have a look at the original dial light. The irony about the dial light, because of its placement, it actually lights up the inside of the radio more than the front of it, so it's not really the greatest design when it comes to that, but you know, it does work, I guess, and it, you know, it's more of a cosmetic thing, really, a dial lamp, if I'm honest. So let's get this power cord changed. Right, new power cord's wired in. A lot better than this old mangled thing. When you see that, that's how you know someone doesn't know how to solder properly. When they even melt the insulation like that. And as you can see, I did not melt the insulation, so I guess whoever did this wasn't very experienced or didn't care. Anyway, well, it's all back together, so I think it's ready for a test drive now. This room is shielded, but it I'll hopefully still get the ABC. That's my goal. If I can get the ABC in this room, I'm doing good. Something there. I think that's the ABC there. That helps. It's doing pretty good in here, I tell you. This room is shielded.
But it's hard to keep up.
You can hear all the stations.
And then he goes down and the line is around the block. This is the black pen.
Engagement reached to 60% on all jewellery. Years old, I believe, standing on stage with his son. Also,
Yeah, I'm pretty sure that's the ABC there.
So not too late for me.
Exactly.
Get back into it.
And see if he gets re-elected. We'll know that they've fully endorsed him. Well, singles now have a new way to meet prospective partners online after a company
I'll take it out of this room and I'll test it out in another room that isn't shielded. Because I can tell you right now, it'll be a lot better in another room.
Take a long ride.